Hello everyone. My name is Mahita. I'm here with my team Harini and Karthik. Today we are going to present our survey on image captioning. Image captioning is a fascinating AI technology that enables computers to see and describe images in natural language just like a humans do. From helping visually impaired individuals to making self-driving cars smarter, this technology has a wide range of real-world applications. So throughout this presentation, we'll explore like how image captioning works and what are the challenges and the future scope of the image captioning. What is the image captioning and why it matters? Like image captioning is a process where AI generates a descriptive sentence for an image. The goal is for the system to analyze the image and produce a meaningful description in natural language. This helps computers see and understands like humans do. Why it matters? Why the image captioning matters. It bridges the gaps between the vision and the language and enables AI to interpret the images and describe them in words, making technology smarter and more interactive. For example, imagine a blind person using an AI tool that can describe images aloud, helping them understand their surroundings. And we'll be seeing the real world example like here, how Tesla uses image captioning, like self driving cars rely on cameras and AI to see their environment. The system generates the captions for the objects like pedestrians and the traffic lights and road signs. These captions helps the vehicle make decisions such as slowing down when detecting a pedestrian. For example, a Tesla might generate a caption like pedestrian detected on the road to trigger or stop or slow down the response. Without image captioning, autonomous vehicles wouldn't be able to make sense of their surroundings. So we're gonna see like what are the tools and techniques we used in image captioning. First one is like a CNN. CNN is used to extract the features from the image, and CNN analyze the different parts of the image, such as the object patterns, and understand its contents. Like it act like a eyes of the AI, extracting important image features like object color and the patterns. And next one is a recurrent neural network. It is used to generate a text descriptions like RNN work by analyzing the sequences of data, making them useful for generating a grammatically correct captions based on the image. Like it work like a storyteller, converting a image features into a meaningful sentences. And next one is like a LSTM. It's long short-term memory networks. It is used to improve the sentence quality by remembering important image details and making the captions more accurate than the RNN. And next one is a transformer models. It is like a more advanced models. In the transformer models, they provide a better accuracy, fluency in generating the captions, and they help AI understand more complex images better. And next one is a pre-trained models. In the pre-trained models, we have a two types. One is a CLIP. It's like a open AI. It connects the vision and the language, make AI understand images more naturally. And next one is a Google's image captioning models used for the larger data sets and advanced AI to generate high accurate captions. And next will be continued by Harin.
Coming to the architecture, this architecture diagram shows how AI can look at an image and describe it in words. The process starts from image feature extraction, where AI picks out the important details from the image, just like how our brain notices objects, colors, and patterns. At the same time, any existing captions or text are converted into a format that AI understands. Then a powerful AI model called Transformer processes both image and text. The encoder understands the image and the decoder uses the information to predict the next word in the caption step by step. This technology is used in automated image captioning, helping visually impaired users understand pictures, improving search engines, and making social media smarter by automatically describing uploaded photos. Coming to this image, it represents a captioning system that combines a convolution neural network and a long short-term memory network. The process starts with an input image, which is analyzed by the pre-trained CNN to extract important features. These extracted features are then passed through a linear layer to adjust the dimensions before being fed into an LSTM network, which generates a descriptive sentence for the image. The LSTM begins with a start token and predicts the first word of the caption, such as giraffes. The predicted word is then used as an input for the next step to predict the next word, like standing. And this process continues until the model generates an end token, marking the completion of the caption. At, at each step, a softmax layer selects the most likely word from a vocabulary, ensuring an accurate and meaningful description of the image. Here we can see a AI generated image from the chat GPT. When we gave an image, it shows what's happening in the image. Like the dogs are playing a tug of war and other dogs are eating and observing the environment. So this is one of the example of image captioning using AI. Coming to the problems of AI image captioning, one big issue is inaccurate or biased caption. If the AI is trained on limited or non-diverse data, it might create incorrect or culturally biased descriptions, missing important details. Like in the example given here, the AI have predicted it correctly that it is a rock, but it has missed the important details like it is a statue. Another problem is the mismatch between the images and text. Sometimes the AI struggles to correctly match words to what it sees, leading to a mistake like calling a dog a cat as a dog or misinterpreting actions in the image, like we have seen here. It is also difficult to evaluate AI generated captions because different words can describe the same image, trying it hard to judge if a caption is truly correct. Plus, AI aren't always easy to explain. Lastly, there is the issue of poor adaptability. AI models trained on high quality images might not work well on real world pictures like low lighting, blur, or cluttered backgrounds. These challenges show that while AI captioning is impressive, there is still room for improvement. The next slides will be continued by Karthik.
Coming to challenges, image captioning means using AI to describe pictures with words. Even though AI has improved a lot, it still has some big problems. One of the biggest challenges is data quality and diversity. AI learns from many pictures, but if the pictures are not valid enough, the AI may struggle with the new images. For example, if AI only learns from the city pictures, it may not describe the village also, since correctly. Some AI models also shows bias, meaning they make unfair or incorrect captions based on the limited training data. To fix this, researchers are working to train AI with a wide range of images. And another challenge is matching images with the right words. AI must understand what's in a picture and describe it correctly. Sometimes it makes mistakes like calling a cat a dog or missing important details. New AI models like CLIP and BLIP are better at linking pictures with words, but mistakes are still happen. The third problem is checking if the captions are correct. There are many ways to describe the same picture, and all can be correct. For example, a child is playing, and a happy kid is running. Both describe the same image. Since there is no single correct answer, it's hard to know if AI did a good job. AI also works like a black box, meaning we don't know how it makes decisions. And finally, AI struggles with different types of pictures. AI models trained on clear, bright images may not work well on blurry, dark, or complex pictures. In real world, images come in many conditions, so AI needs to train to handle all kind of situations. And overcoming AI captioning limitations. To make AI captions better, scientists and images engineers are working on new solutions. Improving data and removing bias is the first step. AI should learn from a mix of different pictures so that it works well for everyone. One way to do this is by adding some small changes to the pictures, data augmentation to help AI understand different situations. And another solution is improving how AI connects pictures with words. Some new AI models use better training methods to correctly match images and captions. For example, contrastive learning helps AI find the best words for each picture, reducing the mistakes. And making AI work better with real-world images using is also important. Instead of only training on perfect pictures, AI should practice with all kind of images, including blurry and low-light ones. Some AI models can now learn by themselves over time, making them smarter without needing as much human help. By using these solutions, AI can make fewer mistakes, work in more situations, and give the better descriptions that are fair and useful. And coming to the future scope, in the future, AI captioning will be much smarter and more useful. One major improvement will be real-time and multilingual captions. AI will be able to describe pictures or videos instantly, which will help blind people and improve accessibility. It will also translate the captions into different languages, helping the people all over the world. And another excitement change is AI working with augmented reality, virtual reality, and robots. AI captions will be useful in AR glasses, helping users understand the surroundings. In robots, AI caption will allow them to describe what they see, which can help in the hospitals and factories and daily life. AI will also improve by understanding emotions and context. Instead of giving simple captions like "a woman is smiling," future AI might say "a woman is happily celebrating her birthday." This will make captions feel more human and natural. Overall, AI captioning will become much better, more accurate, and more useful in daily life. It will help in many areas, including education, healthcare, self-driving, and entertainment. And as AI improves, it will be able to describe the images more like human one. Thank you.